Yes, so we try to understand what kind of technologies can help us to perform remote sensing, which are not satellites, for two principal reasons. We know today it's possible, for example, download satellite image for free on internet, but sometimes can happen that the resolution of these images is not enough for our analysis. And also there are countries which don't have economic resources to pay for their own satellites. For this reason, we would like to propose to use the unmanned aerial vehicles to perform localized and small-scale remote sensing. The unmanned aerial vehicles are, for example, drones, copters, and in our case, we used a stratospheric balloon. We choose to work with a stratospheric balloon because it's a very cheap option. We paid for all our instruments the amount of 2,500 Australian dollars, and also is a very robust option, and it's easier also to understand and implement. In fact, it's also faster to implement, and we spent just 1 week to finish all our project. A stratospheric balloon, of course, is composed by a balloon full of helium, and also the first part of our experience was to build the payload with all the instruments to perform our analysis. In the image on the left, you can see the internal structure and also the external structure of our payload. The external structure is made of polyester, and the internal structure is summarized in the graph on the right of the slide. And the most important components were the Raspberry Pi microcomputer, which control all our instruments inside the internal part of the payload, and also 2 cameras which works in the spectral range of visible and infrared. I would like to show you a video made by my friend and colleague Lisa Stojanowski, which is a good summary of all our experience, because we collaborated also with other participants during the program. And in this video we will see the first part with some experts that help us to implement the payload, also the day of the launch with all our webcast, and of course some beautiful video that we took with our balloon. So, okay, enjoy the video. We have not the audio, so I will explain a little bit with the video. Okay, these are our experts that are explaining how we can use this payload and all the functional things that we can do with this technology. My friends in here are explaining better the internal part of our payload, in the specific the Raspberry Pi microcomputer, because it's very, very cheap and also is light, so can be a very good option for this kind of technologies, because of course inside the payload we need to put inside very light components. You can see one of the cameras that we used to take the video, and of course we did also several tests to see if our payload was robust. And this is the day of the launch with all the webcast. There were several people, because we also send our experience on the internet to show these experiments all around the world. you can see now that they are they are preparing the balloon very slowly because it was a windy day. Okay. You can see that the structure is stable because some guys during the experience build the fin to make the structure stable to take all these pictures and video. Now we are watching the moment where the balloon explodes, and after this moment a parachute starts to fall down with our payload in a safe way. Okay. Yeah, there is a moment where we can show okay, this is the moment where when the payload was falling down, and you can see in a few seconds also the shadow of the parachute with our payload. Yes. And after a few hours, a group of 6 people picked up again our payload. This is our supervisor during the experience, and this is all the group. Okay. Now, after this, during this video, we saw more or less the first part of our experience. Build the payload, launch the balloon, and pick up the balloon again. Now, I would like to show you the second part of our experience. In this slide, you can see the flight path of the balloon, because inside the payload we put also a GPS. We start from the Mount Barker area in the south of Adelaide City, in the south of Australia, and then we picked up again the payload in the area of Cobblettville after the balloon arrived to the higher altitude of 36.4 kilometers. We use the data from the balloon to perform our remote sensing analysis. I would like just to give you a little introduction of this discipline because this is a scientific field where we can analyze a surface or an object with our technology which is not in contact with the study object. We have to use an energy source. In our case, the source was the sun, and because it gives us the radiation or incident energy which were going in contact with our surface is split in 3 different parts, but we use just the reflectance energy to calculate the normalized difference vegetation index, or NDVI, which is an indicator to describe the health of the vegetation. In fact, healthy and unhealthy vegetation reflect different percentage of the reflectance energy, and the NDVI is described by the formula that you can see it, and we can use the spectral range of the near infrared and the visible red range to obtain a number or a value inside a range from +1 to -1, and all the values more than 0 indicate healthy vegetation, and value less than 0 indicate unhealthy vegetation. So, for our analysis, you can see 2 examples, because when we took again the data, we had to assign a coordinate system. So we use the Geographical Information System, or GIS, to georeferencing all the images. And we assign to each point of our images a geographic coordinate, and use, of course, a base map. And you can see that after the georeferencing, the images are not totally flat but adjusted. Okay, this is an example of the final result. You can see the image indicated by the number 1 is the visible image. With the number 2, I indicated the near infrared image, and with the number 3 is indicated the base map. The NDVI is indicated with the bright colors, and we can see in this image, for example, that all the values of the NDVI are all positive, which means that the vegetation inside our area is healthy. In the specific, we can see that the higher values are located in the crops, because of course there is the irrigation that helps the vegetation and the crops to be healthy. So for conclusion, we saw like a stratospheric balloon can help us to obtain good and high resolution data. We can perform several analyses with the data which came from our payload, and we can compare also this data with the data which came from the satellites, for example. And also we can extend this kind of analysis, for example, to monitoring the crops in the agricultural fields, and we can, of course, do localized remote sensing analysis if we need to know the characteristic of a specific area. I would like to thank all the participants and the teaching staff of the program, and there are, I think, some people. Can you stand up, guys?
Oh, that's me.
I would like to introduce you, Gustavo, Josh, and Lisa. And I would like also to say thank you for the attention. Thank you very much.